Physics, the very foundation of our understanding of the universe. The study of how our universe works, from the tiniest particles to the vastness of space. It's a fascinating subject, but sometimes what we learn in textbooks feels different from what we see in real life. The theories seem so neat and tidy on paper. Why is that? Well, textbooks give us the basic rules, the theories, the perfect scenarios. They present an idealized version of the world, but in the real world, things are a little messier, a bit more complicated. Variables we can't always predict come into play. That doesn't mean the laws of physics don't apply, it just means there's more going on. Real-life applications often involve multiple factors interacting in complex ways. This essay is all about bridging that gap, understanding the connection between the clean equations in a textbook and the exciting, messy reality of physics all around us. By exploring real-world examples, we can see how textbook knowledge translates into practical, everyday phenomena. Let's start with a simple concept: inertia. Inertia is a property of matter that resists changes in motion. It's a fundamental principle in physics that helps us understand how objects behave. You've probably heard that an object in motion wants to stay in motion. This is a key part of understanding how things move in our world. That's Newton's first law of motion, and it's a great example of physics in action. This law tells us that an object will not change its motion unless a force acts upon it. Imagine you're kicking a soccer ball. This simple action can teach us a lot about inertia and motion. It's sitting still on the ground, minding its own business, until you apply a force, your foot. The ball was at rest, and your kick changes that. Then, the ball takes off. It starts moving because of the force you applied. But here's the thing, the ball wants to keep moving in the same direction at the same speed. This is inertia in action. It takes another force, friction from the grass, air resistance, or hitting the net, to stop it. That's inertia. Without these forces, the ball would keep going forever. Next up, sound. We experience sound every day. But have you ever stopped to think about what it actually is? Sound is a form of energy that travels in waves. Imagine a tuning fork. When you strike it, the prongs vibrate back and forth. This vibration creates areas of high and low pressure in the air, which travel outward as waves. These waves reach your ear, causing your eardrum to vibrate. Your brain interprets those vibrations as sound. The frequency of the vibrations determines the pitch of the sound. High frequency, high pitch; low frequency, low pitch. Section 4. Electricity, the flow of tiny particles. Electricity is a fascinating phenomenon that powers our modern world. Electricity is another great example of how physics works in real life. It's the invisible force that lights up our homes, powers our devices, and keeps our cities running. Electricity is all about the flow of charged particles, usually electrons. These tiny particles move through conductors like wires, creating a flow of energy. Think of a simple circuit, like the one you might create in a science class. It's a basic setup that helps us understand the principles of electricity. You have a battery, a wire, and a light bulb. These components work together to create a complete path for electricity to flow. The battery acts like a pump, pushing electrons through the wire. It provides the necessary energy to get the electrons moving. This flow of electrons is called current. Current is measured in amperes and is a key concept in understanding electrical circuits. The wire provides a path for the current, and the light bulb offers some resistance. This resistance is what causes the light bulb to glow. Ohm's law tells us how these three things are related: voltage, the force pushing the electrons; current, the flow of electrons; and resistance, the opposition to the flow. Understanding this relationship is crucial for anyone working with electrical systems. Section 5. Physics in action, a whole new perspective. From the arc of a soccer ball to the music we hear, physics is everywhere. Understanding the basic principles of physics can change how we see the world around us. Suddenly, everyday experiences become more interesting. We start to notice the forces at play, the energy transformations, the wave patterns. It's like having a secret decoder ring for the universe. Section 6. Keep asking questions. The most important thing is to stay curious. Don't be afraid to ask questions about how things work. Why is the sky blue? How do airplanes fly? Why does a spinning top stay upright? The more we explore, the more we realize how much there is to discover. So, keep your eyes open, your mind curious, and never stop exploring the wonders of physics.